Hi everyone, welcome back to Chem Help ASAP. In this problem set video, we are going to do some problems that deal with weight versus mass. We are going to take a look at the different states of matter and phase changes. We are going to learn to differentiate between pure substances, compounds, elements, and different types of mixture. And we are also going to take a look at the difference between chemical and physical changes. Let's get started.
Starting with our calculations of weight based on mass. Here is our first problem, calculating weight. The question reads, what is the weight of a person on Mars if their mass is 110 kilograms? And it gives us the gravity of Mars as 3.71 meters per second squared. Let's first write down our equation for calculating weight. So weight is simply your mass times the gravity of whatever planetary body you are on. In this problem, we are on Mars. Now we were given our mass, that is 110 kilograms, and we are also given the gravity on Mars, that is 3.71 meters per second squared. We simply multiply them, and we get a weight of 408 newtons. Remember, a newton is simply a kilogram times meter over second squared. So we didn't have to do anything with our units here. Our second problem reads, when the Apollo mission landed on the moon, the weight of the lunar module was 24,000 newtons. If the gravity on the moon is 1.6 meters per second squared, what is the mass of the lunar module? In this case, we have the weight. Now we want to solve for the mass. We still are going to use the same equation for this problem. Our weight equals mass times gravity. We're just simply solving for a different variable. So in this case, we know the weight, so let's plug in our 24,000 newtons there. We don't know the mass, but we do know our gravity is 1.6 meters per second squared. We simply solve for mass, and we get our mass as 1.5 times 10 to the fourth kilograms. Let's do a little bit of work identifying states of matter. Here is a table with different items in it, and we just want to identify the state of matter of each of these items. So our answer is either going to be solid, liquid, or gas for each of these. Starting with air. Air has no definite volume, no definite shape, therefore it is a gas. Next we have a popsicle. Now a popsicle has a definite volume and a definite shape, therefore it is a solid. Third on our list is silly putty. Silly putty has a definite volume, but it does not have a definite shape, so therefore silly putty is actually a liquid. That may feel a little bit weird, but if you have silly putty, try putting it in different vessels and you will see that over time it will take the shape of any vessel you put it in. It is simply a very slow moving liquid. Our last item is a table. It has a definite volume, it has a definite shape, so it is also a solid. Next, let's work with phase changes. We will only do phase changes between solids, liquids, and gases in this problem. Our first action is crushing rocks. Is there a phase change? And no, there is no phase change with crushing rocks. We're simply changing the size. Next, we are going to heat some water for tea. This is a phase change from a liquid to a gas, so this is the vaporization phase change. Next, we are going to look at tearing paper. This again is a change in size, not a change in phase, so no, there is no phase change there. Our last action is when frost forms on the grass. This is a phase change, but you may not recognize it as a deposition phase change. This is actually a gas going to a solid. It can also sometimes be a liquid going to a solid as well, but it is definitely a phase change. Our next problems are going to give us practice in classifying different materials. Thermometers used to be filled with mercury, but are now usually filled with rubbing alcohol. Classify mercury and rubbing alcohol as either an element, a compound, a heterogeneous mixture, or a homogeneous mixture. Let's start with mercury. If you have your periodic table handy, you can actually find mercury on the periodic table. Its atomic number is 80. So mercury is an element. Rubbing alcohol, on the other hand, is not found on the periodic table, so it is definitely not an element. Now we need to decide, is it a compound or is it some kind of mixture? If you have a thermometer in your house, it is probably a digital thermometer, so you may have less real-world experience with thermometers filled with rubbing alcohol. But rubbing alcohol is a molecule or a compound. Now, both mercury and rubbing alcohol are pure substances. Neither are mixtures. Our next problem reads, table salt is a molecule and a pure substance. If it is dissolved in water, how does its classification change and why? This is something you have probably either done at some point or at least seen someone else do. When we dissolve table salt in water, we create a mixture of both salt and water. The question now is, have we created a heterogeneous mixture or a homogeneous mixture? So when you think about the salt water you created, is it a uniform mixture? Yes, it is definitely a uniform mixture. So dissolving table salt in water creates a homogeneous mixture. Finally, let's spend a little bit of time on physical and chemical changes. Our first question reads, fireworks shows are fun to watch. When a firework explodes, has a physical or chemical change occurred? Hopefully you have had the pleasure of enjoying a fireworks show and know that when a firework explodes, there is definitely a change in color. Now, usually we aren't close enough to feel this, but there is also a release of heat. These are both indicators that when a firework explodes, it is a chemical change. Here is our next question. Dry ice is often used to keep items cold during shipping. If left out, the dry ice sublimates. Has a physical or chemical change occurred? If you remember back to our phase changes, you know that sublimation is a change from a solid to a gas. Phase changes are not chemical changes. They are simply physical changes. So sublimation is simply a physical change.
One of the best ways to become more comfortable with these definitions and the terminology is, of course, to practice. So as you're going throughout your day today, think about what state of matter are you looking at or using, and has maybe a physical or chemical change happened. I hope this video helped, and thanks so much for watching.